Everyone, my name is Jan Kala. I'm a software engineer from Genf, and today I have prepared a presentation about how you can buy some cheap router on the internet and you can turn it into a networking test lab with some open source software so you can test your applications that you're developing. Here's the agenda for today's talk. So first of all, I will introduce you why you might be interested in such a thing and what led us to do these steps that I'm going to describe. And then we will go through 3 levels of setting up that hardware you can see over there. And the levels are sorted by difficulty. So first of all, we will set up some kind of firewall. That's the most easiest thing that you can do on the router. Then we will set up a captive portal. And finally, we will do something called penetration testing, which is a very fancy name for changing the traffic of the application between the application and the backend. So let's start with the introduction then. I will talk about what I do briefly. So I work at Genf on an application called Genf Trust. And this, you can see that this is the application that we're developing here. It's a business VPN based on a WireGuard protocol. And usually this is the only screen that the user can interact with. As you can see here, it has only one button. And you might think that, well, if it has one button, then it's pretty easy to develop. It's pretty easy to deploy and then debug issues because, well, users can't mess it up, but they can. They're usually using the application in a different environments all over the world. As I said, we're developing a VPN which is in a way of the network traffic, and users are using it in McDonald's, in offices, and in airplanes or trains. And usually they do complain about our application first. As I said, it stands in the way of the network. And they complain about that they cannot connect in the McDonald's when our VPN is on, or that it doesn't work in their office or at their homes, or on the airplane that they're traveling to OpenAlt, for example. So we have categorized these environments into these 3 main categories, like networks with captive portals, some networks with strict firewalls, or even networks that do utilize both. And we were thinking about a way how to test these categories, how we can test our application so we can create a resilient app. So for captive portals, you can just go into your nearest McDonald's or KFC or Starbucks and test your application there. That's fine. But, well, it costs money of your testers, and they're getting less and less fit as they're eating it. And then for the strict firewalls, well, you can go to the office of the client. If it's in Brno or Prague, it's fine. If it's in London, well, your company won't be happy because it will cost some money, but you can still go there. The problem is when it's not working in client's home, so you don't want to spend the whole day debugging in their home. And the worst part is the condition when it doesn't work on an airplane or an airport, because then you would have to travel all over the world, or maybe at some specific airplane which goes just from London to Tokyo, and you just don't want to do that. So you need something in your home or in your office that you can simulate these conditions. You can set up or spin off some networks that will mimic what you see here, and you can test on it in the comfort of your office. And while we're now specifying the requirements, we will add 2 extra requirements. It would be really good to know how does your app behave on a malicious networks, for example. So if the client or user will connect to someone who's doing an MITM attack, do you know how your app behaves? Or if the app will receive some unexpected response from your backend, do you know how your app behaves? And you usually don't want these answers from the customer because it's not a friendly answer, it's usually a complaint. So we were looking for the solution for all of these requirements that we have just specified here, and we came up with some solutions, but the best one that we found out works the best for us was the OpenWrt, which is an open source operating system for routers. This is the definition of the OpenWrt. It provides fully writable file system with package management. So it sounds that we can install packages there, we can run them and configure it. That's great, we need that. And it enables for full customization to use device in ways never envisioned. Yeah, that's cool. It's grabbed from the project's website. So we need exactly that. The full customization is what can enable us to create those or fulfill those requirements. So how to get it? How to get the hardware that can run the OpenWrt software? First option, as the name of this talk suggests, is that you can get it cheap. Just search your Facebook Marketplace, search for some router. Only two things you need to check is that the hardware is supported. So for this purpose, we have table of hardware on the website. And if it's supported and there are steps how to flash it, then you will just flash it and you have it ready. Usually when I see that you need to flash something, I get scared because it requires a lot of some hardware and steps and a lot of focus and concentration. And it's not like that. This was my setup while I was flashing this box in here. So the router is right there. The notebook that was doing or serving the operating system for the router was in the middle, and I use this one just to read instructions because you lost the internet access for the middle one. And it usually works that you connect the router to the laptop peer-to-peer. You spin off some file system or file server on the middle laptop, and you put there a zip file in some specific path, and then you turn on the router in some boot up sequence that will try to grab that file from your laptop. So it's pretty easy. I was done in 5 to 10 minutes. I didn't even use the duct tape behind the router. And the second option, when you're lazy and you have a lot of money, you can just buy it. This might be familiar for some people from the tourists that are running around here. So this is the option that we have decided for our office. We bought the Tourist MOX 6, Wi-Fi 6, and it comes pre-flashed with the OpenWrt, and you can just work with it. So this is also an option. I have experience with both of them options. As I said, this one we have in the office. The other one is right here. I use it for my personal use. So I wouldn't really recommend one of each. Each has its pros and cons. So you can test them out. So let's go through the first demo. I have overview of the UI. So let's see how the router looks like, how the interface. So once you connect to that router, usually the same way you would connect to your home router or the router provided by your ISP, you see some kind of dashboard. This dashboard is not there by default. It's one of the packages, so you can even install packages into the UI. So that's fine. So I did install this dashboard, and you can see some basic information there. If you're connected to internet, what's your system parameters, the uptime, model of the router, and firmware version of the OpenWrt. Then if you're connected to internet, and etc. Then you have a bunch of other options there. As you can already see, it has more options than the basic routers from your ISP. But the option that you will use the most often is the network. Now that network contains these pieces like interfaces, firewalls, and viral settings. So let's start with the interfaces. On the interfaces, you can see that those are the basic building blocks of your configurations. So it's like a rule book of what the network should have for the IP address, how the DHCP should assign the IP addresses to devices, and so on. So we will create a new interface as well to show you how easy it is. I'll just give it some nice name here. I'll switch to protocol to static address, and the device I'll leave unspecified. I will stop here for a second as well. So as you can see, there are many options already, and you don't have to fill them out. You can just ignore some of them. This is I think, a little minus of the UI, that it gives you a lot of options, but you don't have to fill all of them. So you can just ignore some of them. So yeah, in here I'm assigning some IP address to that interface. I'll specify the net mask. It's pretty easy. And yeah, you can see advanced settings, firewall settings. I'll assign a new firewall zone. I will talk about the firewall zones soon. And I will spin up a DHCP server just like that, just with one click of the button. There's a start of the IP address range, and then the limit of the devices. And only thing you will need to add there is the DHCP option, so that the DNS server is being propagated in the DHCP offer packets, and that's it. So yeah, now as you can see, the interface, when I made some changes, the changes are not applied yet. The system works in a way that you prepare all the changes and then you commit them all in one transaction. So you don't have to worry that like one little change will break your router. You can still revert them if you made some mistake. So I will now go. You can also see it there on the top bar. I will now go and apply those changes. It takes just a few seconds. And you can see that the new interface is now here. And I do have some error in there. Yes, that's why I think that the UI is useful when you're starting with a system like this, because it will tell you that something is not correct, and you can see that the network device is not present yet. We will fix it in a short while, but before we'll start fixing it, I will move to firewall, and we'll adjust the firewall settings there. So this is my new network in a new firewall zone. And what is the firewall zone? I imagine it like a building. The router is a building, and each firewall zone is like a room in that building. So if we have room called LAN, then WAN, which is the internet. And if you want to create doors between those rooms, you just adjust these rules so that, for example, LAN can access internet and so on. As you can see, our new room has no doors, and we don't want that. We will assign some kind of doors there. So let's change it so our new firewall zone is able to access the internet. Now, in this step, I'm accepting input from whatever device on the network to the router itself. Does anybody know why this might be useful? It's very useful for the DHCP itself, because I found out when I did reject the input, well, the devices that do connect to the network is trying to get the IP addresses, but the firewall is rejecting it, so they are stuck with no IP addresses and nothing is working. So the input is now accepting the DHCP packets and so on. And yes, in here, I'm allowing forward to the destination zone, which is WAN, which is the internet. So my new firewall zone can now communicate with the outside world. I'll save that. And let's move to fixing that error that we saw on the interface settings. So let's go to the network tab, to the wireless section. It's up, yes. And as you can see, this specific router has two radios. One of them is 2.4 gigahertz radio. The second one is 5 gigahertz radio. And as you can see, the networks that are being transmitted from the radios doesn't have to be the same. So I'm having one network on the 2.4 gigahertz radio. I'm using that one for internet access. So the router itself can be a client of some other network or Wi-Fi. And at the same time, the other radio can transmit the other networks, multiple of them. So I'm currently running two networks there, the captive portal and mitmproxy. I will just add to that list another network. And I will choose the 5 gigahertz one. usually found out that it's better when you have multiple networks around you. Usually, a lot of them uses 2.4 gigahertz, and the 5 gigahertz spectrum is less congested, so the 5 gigahertz works well. And because I studied security at this school, I will add some key there. And it's not admin or something like that, not even password 123. And again, another lot of options, like you can filter MAC addresses, you can isolate clients, some WLAN roaming, VLAN. And again, the network is now waiting for me to apply those changes. So let's see if the changes did apply correctly. And it seems they didn't, but they did. So yeah, the network is now ready for the clients to connect to. I will show it on the iPhone that I'm having connected to my MacBook. So I will start the Wi-Fi. You can see the network is directly connected. New connection has been made. You can see the signal strength there. The network is working. And the IP address that I have specified there is assigned correctly. These are the DHCP options of the servers. So let's just check that the internet is working, and it's working. So yeah, voila, I have my network spin up. I can go and do some testing there, I hope, finally. So let's start with the first level. Now that we have the network, we can do some adjustment and changes to it, and we can for example, block something there. Yeah, that's the first condition that we can test on some firewall block. So this is the plan that the device that's running on some dedicated network will be sending traffic to the router, and the router will be blocking some of the packets, and the rest of the traffic will go unnoticed. So this is the plan for our next demo, which is the firewall block on the router. So let's start right away. Let's go back to the network tab, firewall section. And here are the zones. And the zones, for each zone, or the doors between zones, we can specify traffic rules. That's the firewall blocks that we will create. So in this example, I have decided to block HTTPS, or the TCP traffic that's heading to port 443. My source zone will be the new zone that I have created, the OpenAlt. And destination zone will be just any zone, like whatever packet you will see from this zone heading anywhere dedicated for port 443, just drop it. So we can create firewall rules easy as that. Another bunch of settings, you can match devices, restrict to address family, so on, time restrict the firewall rule. There are a lot of options, again. So let's save it and apply it, and let's take a look at the device, how the device behaves with this firewall rule. Yeah, and surprise, surprise, the internet is not working properly because I'm blocking it. So let's fix it once again and delete that firewall rule. And as you can see, the same second that the rules were applied, the internet started working for Safari. So in this case, we were kind of testing how Safari behaves when we apply some random firewall rule throughout the day. And we see that it's pretty resilient. When you remove that rule, it reloads the page automatically. I didn't have to touch anything on the device. So this is the first condition, and we have the first results already. So let's move into the level 2, which is captive portal. And when you imagine a captive portal in the train or in the airplane, they seem complicated. They sometimes are, because there were no standard for captive portals for a long time. So I was first scared of them, but it turned out that there is a very clever package that we can install on the OpenWrt, which is OpenNDS, which is network demarcation service, and it offers me high performance, small footprint, captive portal, etc., etc. But I was already sold on the high performance, small footprint, because that's exactly what I need. I need something that is very easy to set up, just start it, and I have a captive portal ready. So yeah, let's do that. So what do we need to change in our infrastructure? Almost nothing, yeah. We have still the device in here. The device will first send some HTTP traffic on the router. The router will return the captive portal page. Then the user will have to accept some terms or something. And once it's done, the traffic then go to the internet. So let's see how it can be done with the OpenWrt. So that's another demo about the captive portals. And now I'm not in the UI anymore. I'm connected to the router via SSH. And I'm going to show you some utility, which is called UCI, Unified Configuration Interface. And that's the... I need to run the video. So Unified Configuration Interface, which is running in the background of the UI that you have seen. So whatever you do in the UI gets translated into this Unified Configuration Interface commands, which are then applied on the server. So as you can see here, I have one interface or network already prepared. It has some IP address that you can see there, net mask, DHCP settings. So whatever you see in the UI can be seen in the SSH or the command line as well. So let's clear it. And I will just check that the OpenNDS is already installed. You can use OPKG to install packages on the OpenWrt. There's a package manager there. And you will just OPKG install OpenNDS and it's there. So my OpenNDS is now there, installed. I can check that if it's running. It's running, so that's fine. And the OpenNDS comes with this little utility called NDS control, and you can get the status of the running instance on the router right away. So in here, you can see that the router that, is running on some kind of, I will show it like this. Router is running on some kind of interface in here, that we have some URL that's serving the captive portal page. And then there's down there's a list of clients. Currently, there's no client connected, so this is expected. Yeah, interface and some other information. It is very helpful when you're debugging the instance, because you can toggle some parameters of the OpenNDS itself. You can see if they were applied or not. So what I'm going to do on the device, I'm connecting to that captive portal. And you can see, yeah, the captive portal page is loading. It's very slow because this is very weak hardware. But in the NDS control, you can see that we have first client connected. We have some information about the IP address of that client, about the MAC address of that client, and some info about the session. So that's nice. So let's then accept the terms of services on the device. And yeah, once again, it's very slow because the hardware is pretty weak. I do have much better experience with the Theresis, so yeah, this is not an advertisement, but good job. And yeah, finally, after a couple of tens of seconds, we can see that the device did accept those terms and services successfully. We have information about when did the session started and ended. And let's check on the device that the internet is really working, that it's not just somebody pretending that the internet is, yeah, it's working, so that's fine. So that's cool, but you could get the same result in the McDonald's or the KFC, right? Well, something that differs us from the McDonald's and the KFC is this NDS control utility, because what I'm going to do next is that I'm going to de-authenticate my device from the session. So as you will see in the status, there are no clients connected to it, but my device is connected to it. So how does the Safari behave in this way? And you can see we found out the first kind of issue that the Safari thought until this point that, well, the internet is working, everything's fine, but suddenly it stopped loading pages. So we see that, and the operating system, which offered us the captive portal automatically, is not doing that anymore because it also lives in a kind of I'm connected to internet world. So let's check some HTTP page, which should redirect us back to the captive portal page. You can already see that the IP address did change to the IP address of the router. And again, it's also taking some time, but we are getting that captive portal page back. So this is the difference between testing on some network in the wild, that you can control the captive portal, you can control when the clients will disconnect, if you can keep their sessions for 24 hours or just a couple of minutes, and so on. So this was great for us to see how does the VPN behaves in those conditions, and I believe it can also benefit some of you as well. Yeah, this new session just started 8 seconds ago. So that was the captive portal. That was, again, pretty easy. We didn't have to do many changes in the infrastructure of our testing network, and we just installed one package and started. It's nothing too complicated. So let's move to the level 3, which is called penetration testing. And for this, we need one extra package, which is called mitmproxy. Free and open source interactive HTTPS proxy. That's great. Another something that we need, but it's kind of heavy for the routers itself. You could have seen how slow the OpenNDS was on this small, poor router. So how can we solve this situation? Where can we run the mitmproxy? Because it's something that I really need. So this is our infrastructure now. We have the OpenWrt router in the middle. The device is connected again to the dedicated network, but we have an extra machine somewhere connected, and the router is redirecting just a piece of traffic to that mitmproxy, and the mitmproxy is then sending it to the internet. So all the traffic goes to the mitmproxy host and then to the internet. That enables us to change the traffic because the mitmproxy, as you might have read there, is interactive. And I will show what is the interactivity of the mitmproxy. So let's start this demo. And now at this point, I will show you the routing rules that I'm applying on the router. So whatever comes from the IPs of this range, 10.0, 0.8.0, and so on, and heading to destination port 80 will be redirected to the specific host, to the specific port. So this is the adjustment I had to do using the NFT. And now I'm on my MacBook. The same MacBook that's used for configuring the router will be used for running the mitmproxy. So you don't need multiple devices. And this is the interactivity of the mitmproxy. I can run Python scripts as a part of the proxy, which will work on top of the traffic that's coming through the proxy. And the rest of the parameters is just when do I want the proxy to run. So let's see what this script does. I will start the proxy. It has the command line interface, but it also has utility called mitmweb. So you can see the traffic in the web browser. And I'm going to visit example.com. And yeah, you can see some traffic already appearing there. And instead of example.com, I'm getting openalt.cz. So yeah, that's great. What a lovely testbed I just created. You can also, this is more of a showcase of the mitmproxy itself. You can explore the requests, you can explore the responses and details. So this will give you more information about the traffic that you can then include in your script. So I'm not sure if there's anything else on the video. No, it's not there. But that's not it, because this is just a proxy, HTTP one, with redirection of one domain. There's nothing special. We need something more. So let's do it. For doing something more, which in this case will be touching the HTTPS as well, we will just need to add a root cert and mitm1, something that you won't definitely want to do on your personal device. mitm root cert on the device, and then you can redirect not just HTTP traffic, but also HTTPS traffic to that transparent or the interactive proxy, which will be then sending it out to the internet. This enables us to touch the traffic from the app as well, not just the browser, and we can do a lot of things with it. So let's take a look what we have prepared there. And I believe we have plenty of time, so I will do the live demo in here. So in here, I have the iOS device right here, prepared for the demo, and you can see the mitm proxy is prepared in here. So first of all, what I'm going to do, I don't know much information about this app that I have installed on my device. I first want to know what the app does, like in terms of traffic to the backend. So I will just spin a transparent proxy there. I will just check that it's connected to the correct Wi-Fi. Yes, and you can already start seeing some traffic there. It's from the operating system itself. It's trying to fetch my emails, I believe. So don't do it right now. Yeah, I'll just clear it. Now let's go back to the main screen, and let's check what the application does. So it's called Meme Creator, and it does this simple thing that you can select some photo, you can add some text there, that's it. And I can already see in here, in the terminal, some traffic from the app, that when I click the button once again, I can see some request to this URL, which is being redirected. And then another flow is going to fastly.pick some photos, etc., etc. Okay, so this gives me some information about the traffic that's coming from the device, from the application. I can also see the name of the app in here, that it's using CF Network Framework of Apple, some information about the response. Yeah, that's, for example, in the first flow, you can see this one. Yeah, you can see in the response where what is the location of the redirection. So this gives us a lot of information for the script that I'm going to spin. So let's do it right away. Yeah, I want to quit it. And my script is called modify.py. It's a Python script. I won't tell you what it does yet, but I will start it. And as you can see, I don't have to even turn off the app. I can still work with it. So yeah, let's do it like this. I'm going to create some text there. And I don't like the photo, so I will shuffle it. And yeah, instead of some random photo, I'm getting a picture of a Nicolas Cage. And all the time, you can see the identifier in the application. Well, I cannot escape this Nicolas Cage. So yeah, so that's what the script does. It when I open it, one of the flows, you can see that the new domain is not the pick some photos, but it's placecage.lucidinternets and so on. So another like redirection, pretty simple one, but as you can see, it does affect the app itself. And the app is not complaining. Well, it does. It shows Nicolas Cage pretty nicely. So the app, let's say the app is resilient against Nicolas Cage. And if you get bored of it, you can again spin the transparent proxy once again and get some normal pictures again. So yeah, this is what the mitmproxy enables for you, for your testing environment. You can start changing the flows between the backend and the app without touching the backend or the app. You can check if your app does recognize that the traffic is being touched in some way. So, for example, if there's the root certificate installed on the device. If the root certificate won't be there, does your app care? It should. So this is, for example, good for detection of some man-in-the-middle attacks, and some other stuff that I don't know. You can change the data. That's some JSONs that your app receives and then tries to set up in the system. You can play there as well. So let's get back to our presentation, because this gets us to the summary of the talk. So far, we were able to identify some of these conditions on the network. You will find networks, as I said, with captive portals and firewall blocks, some networks that does net64 with DNS64 or 64, then slow, unreliable networks that you can also mimic with the device. Some network traffic adjustments, as we just saw in the latest demo. MITM attack, I don't know. Be creative about all the parameters that the OpenWrt offers you, because that creates even more and more environments than you can test on. I will just give you, this is the environment that we were able to set up in the office, that we have this Turis MOX in the office that's running a couple of networks, and when we are testing our app, we're just switching between the networks. So if you need to test on captive portal, you connect to that network, then some strict firewall rules, penetration testing, and so on. So we're extending it, and when some customer complains about some network environment, we just gather as much information as we can from them. We start our own network in our own office and try to reproduce it there, so we don't have to travel the world. Here are some lessons learned from when I was setting up the environment. So first of all, separate it from your office network. You don't want IT texting you about why this vulnerability has been introduced in the office. So it's a really great idea, because with all those settings, with everything that's available there, it's easy to create some vulnerability. And then I found out that lately the AI is a great help. Before I started using AI, you basically had to learn about everything that you wanted to set up there. You had to learn about every single command and put it into some shape so you can send it on the router. AI is doing a great help of explaining it pretty efficiently, but don't blindly trust it, because that is how can you introduce the vulnerabilities on the router. Then be responsible with Wi-Fi frequencies and channels. We prefer 5 gigahertz, and we lower the signals of the radio as much as we can, so the testing can be done just around the router itself, and it's not affecting people around the whole office. Usually the office buildings are full of different companies running their own networks, and the last thing the office building or a block of flat needs is another 5 testing networks there, because the 2.4 gigahertz networks will just hop from one channel to other, and it's just crazy. So be responsible with that. And another good thing is that set up a WireGuard tunnel to your router or any upstream access to that router, because if you're configuring the router while you're connected to it, and you will do some change in the wireless settings, the radios do restart, which disconnects your MacBook, and there is that mechanism of that you will need to, when you're applying changes, the MacBook needs to kind of confirm it back to the router. So the router applies those changes and then waits for the UI to confirm it. And if it doesn't do that, the router will revert back because it thinks that, well, I broke the connectivity totally, so I will revert to the previous configuration. So setting up some upstream access to the router is better, because in that case the MacBook stays connected to one single network, and which might be your home network, for example. And once the router is able to communicate with it upstream through the internet, it can do that. And yeah, what I found out the hard way is that sometimes restart is the solution. Usually after a couple of hours of setting up the router, you do so many changes that it gets the router into a weird state. And I did find out that it made me mad. I did turn off the router. I went to breathe it off, took a coffee, came back, started the router, everything worked perfectly. So yeah, sometimes after you do a lot of changes, just restart it and it works. So thank you very much. I will give you some time for questions now. Before I will do that, you can add us, the Jamf, on LinkedIn, and me as well. You will get some information about what we're planning to do in Brno, in our Brno offices. I heard that there might be some technical meetup coming on. So yeah, let's stay tuned. So yeah, let's give a bit more space for the questions, if there are any. And it seems it doesn't. Oh, there's a question.
Does the captive portal support IPv6 in full mode? Because examples were IPv4 only.
So yeah, so the question is... Yes, the question is that if the captive portal does support IPv6 in a full mode. I haven't looked into that yet. I was mostly playing with the IPv4, so that's for example a great example of what I'm going to do next. There's another question.
Can I use the captive portal to create my own application and to collect people's addresses in my domain?
So is the question that you want to create captive portals on your vacation and just captive some people in there?
No.
Ah, okay. So what was the question?
McDonald's plays the network with stronger signal, so people log into my captive portal instead of theirs, so I can get their email addresses.
Yes, so the question is now coming from MITM attacker itself. So the question is if he can spin off a captive portal in a McDonald's and capture with a stronger signal the devices around him. And I believe that's possible. That's also part of the detection that we do if you're connecting to a correct network. So it is possible. You can test it out. There's one toggle in there in the network settings where, for example, the router itself can connect as a client to upstream Wi-Fi, but it doesn't connect just based on SSID, but on a BSSID. So it respects the BSSID rather than the SSID. So it's more careful about what you're going to do. But yeah, I believe you can do that. I hope that you'll do that.
If you use the TLS for captive portal, it would protect you because you should not be able to get correct certificate for that domain, but I think usually captive portal does not implement TLS.
Yeah, so there's another answer for the stream. So if there's TLS is used for the captive portal, it will be more apparent that you're not connecting to the correct captive portal based on the certificate. So you should be more secure with the TLS. All right. So thank you very much for paying attention. There's a couple of things that you can just grab. It's on the end of this table. So if you want some notebooks, some mints or something, just grab it. Don't ask me. I don't want to take it back home. So that's it. Thank you very much.